Okay, it says here to write this expression without radicals and using only positive exponents. So what I have here is I have a product of radicals. I have a root 10, or the 10th root of this number, and the square root of this number. Okay, so let's rewrite this. Let's write the 10th root of c to the 5k and the square root of c to the negative k, which is raised to a half power. Here's what we're going to do. We are going to write this as a rational exponent. So I'm going to write this as this. C. Remember that the exponent of your radicand becomes the numerator of your fraction, and the index, or the root, of your radical becomes the denominator of your exponent. So there I've written my radical as an expression with a rational exponent. Let's do the same thing here. But before I can do this here, I have a power here that I need to tend to first. I have negative k. That's the exponent of c raised to the power of 1/2. And remember, when I have a power raised to another power, I need to multiply exponents. Okay, remember, I'm going to write this off to the side. When we have x to the 2nd power raised to the 4th power, that becomes x to the 2nd power times 4, which is x to the 8th power. In this case, I have c to the negative k power raised to the 1/2 power. That means I need to multiply. This becomes c to the negative k times 1/2, which is c to the negative k halves, because k times 1 is negative k, and the denominator of k, which is 1, times the denominator here, which is 2, that equals 2. Okay, so I can rewrite this radical like this. C to the negative k over 2. Okay, let me go back to green. And so far, this piece here, I can reduce a little bit. 5 over 10, I can reduce that. There's a common factor of 5 here, so I can rewrite this as c k over 2, right? Because let's explain that here. 5k over 10, there's a common factor of 5, so I can cancel this 5 and this 5. I divide by 5 in the numerator and denominator. I keep a 2 here, so this is k over 2. Okay? So I've reduced this a little bit, and here now I want to write this whole expression as an expression with a rational exponent, or a fraction. I want my exponent to be a fraction. Now, this whole number in here, is the radicand, okay? And the radicand has an exponent of negative k halves. Now this exponent, remember, the exponent will become the numerator of the fraction, and the root, or the index here, which is 2, becomes the denominator. So this is how this is going to look. This is going to be c to the negative k over 2. That's my numerator because that's the exponent. And then the denominator is 2, which is the root. So this is what I have. Let me go off to the side here again. I have negative k over 2, which is the original exponent of the radicand. That is the numerator of my exponent. And the denominator is the root, which is a 2. Okay? This is what I have as my exponent. Now, we need to simplify this a bit. K over 2 divided by 2 We're having here, what we have here is a division of fractions. And when we divide fractions, it's the same thing as, remember, this 2 is over 1 because 2 is the same thing as 2 over 1. When we divide fractions, it's the same thing as multiplying by the reciprocal of the denominator. And the reciprocal of the denominator is 1/2. So that equals negative k over 4. Because negative k times 1 is negative k and 2 times 2 is 4. So this becomes c to the k halves times c to the negative k fourths. That's what this whole thing simplifies to. Okay? And now, since I have the same base and I'm multiplying, that means that my exponents I can add. So I end up with c to the k halves plus negative k fourths. How do I add these two fractions? Let's go off to the side here again. And we have, let me get purple. We have k over 2 plus negative k over 4. We need a common denominator. The common denominator is 4. I need to change this denominator to a 4. That means by multiplying 2 over 2, I get that. So this is 2k over 4 plus negative k over 4, and that gives you k over 4. So that means that this is equal to c raised to the k over 4 power. Okay? And that's the answer to this. I know this part here may be confusing. There's another way you can do this. Okay? I can do this like this also. In this step, instead of going this way, we could have also done this. We could have written c to the 5k over 10 times, and look at what I can do here. I can write this as a rational exponent. I can take the radicand and I can say this whole thing here. I can say this whole thing is raised to the 1 power. Okay, so I can write this like this. C to the negative k over 2 and everything raised to the 1/2 power. And this 1/2 power represents the square root. 1, which is the exponent of this radicand, over 2, which is the root of the radical. And here's another way you can write that. And then this is what you would have. You would have c to the k over 2 times, and then you multiply powers, times c to the negative k over 4. And that's it, because you multiply k halves times 1/2. And that's numerator times numerator, which is negative k, and denominator times denominator, which is 4. And see how quickly I got to k over 4? I didn't have to do any of this, of multiplying by the reciprocal, etc. And you get to the same place. And now, since you have the same base, you can add your exponents. And we already know this is c to the positive k fourths power. You get the same thing. Okay? We can always use this method where I can write my radicand, whatever it is in there, and I can raise everything to the 1 power. And then just raise everything to the 1/2 power, because then my exponent would be 1, that's the numerator, and my root would be 2, there's your denominator. And then you raise everything inside of the radical to that power. Okay? So this is another technique. You get the same thing. They had asked us to write this expression without radicals. Done. We didn't use any radicals here. And also positive exponents. And we only have positive exponents. I hope you understood this example. I know it's a little bit confusing. Go over it again, and I'm sure you'll understand it, hopefully. If not, bring questions to the classroom. Okay, have fun.